Welcome back to the channel. I have something to show you today. Do you see this? This is a transparent container which I already fill in with water. So I want you to see this. Okay, this is a transparent container. And then I'm going to place a pan into it with a certain angle. And when you look at the surface of this container, you can see, right, the pan seems to be broken, right? It is broken. It seems to be like broken, right? So is the pan really broken? Right, what could be causing this illusion? This has something to do with the topic that I am going to discuss today. So, the topic that I am going to discuss today is called refraction of waves. Are you ready? Let us get started. Now, I want you to imagine you are at a very super duper nice swimming pool like the one that I show you. I wish I could be there, right? So, right, if I am standing at the middle of the swimming pool, right? Could you see that? Look at me. Could you see that my legs appear to be shorter? Am I becoming a dwarf? Right? It doesn't tally with my body, right? When I am in the water, as compared to I stand on the ground, when you see me, it's just like a normal length, normal size, normal height. But when I dip myself into the swimming pool, I'm standing in front, okay, at the middle of the swimming pool, you see that my legs get shorter when I'm inside the swimming pool, right? Why do this occur? Right? There is something which is caused by refraction of the wave. Now, before I could start with the topic of refraction of the wave, feel free to go to the description of my YouTube to download the notes before you fill in the answer. So using the notes might give you some conveniences to write down the answer, to understand the concept better, right? So the refraction of wave is being defined as the bending of wave when a wave travels from one medium to the other medium. Let me highlight the keywords first. Bending of wave, bending is the keyword. When a wave travels from one medium to the other medium, from air to water, from air to glass, from glass to air, from water to air. That's what we call from one medium to the other medium. Now, this is what the results show you. You can do it at home, no worries. All you need to do is just to take a glass, maybe a transparent glass, because you want to see the effect. So you place a spoon or the pan, like what I did just now, right, into the water. And then you make sure the eye level is at the surface of the water. This is what you observe. Right? This situation occur is due to the process which we call refraction of the wave. Now, why wave ever bend? Right? Because refraction is about bending of wave. Wave bend because when wave travel from one medium to another medium, it causes the speed of the wave to change. Right. And why the speed of the wave changes is due to the different densities of the medium. Different medium, they have different density. So that is why, due to the different density, the wave speed will have changed. So that causes the wave to bend. Now, you think of this. If you want to understand this concept better, I want you to think of this when you are in a car. For example, you drive the car on a smooth road and suddenly you just drive straight, no problem with that because all the wheels of the car will go straight. But when you move your car, right, to drive over a sandy road, right? It's due to the different densities of the smooth road and the sandy road, it causes the wheels, maybe the front part of the wheel or one of the wheels to bend, right? To travel a bit slower, and it causes your car to turn. That is called bending. Right. Effect of the refraction, it causes the wave's direction to change. Like your car, from smooth road to a sandy road, it causes one of the wheel to change direction. So the car will change the direction. And it causes a wave speed to change as well. So due to the wave speed that is changing, we use the wave equation. If you still remember, let me write it down. wave equation, V equal to F lambda, where V represents the speed of the wave, F represents the frequency of the wave, and lambda represents the wavelength of the wave. Frequency of the same wave will remain constant, right? Since the frequency is constant, the wave speed is directly proportional to the wavelength. Wave speed changes, it causes the wavelength to change at constant frequency. Now, do you also ever wonder, right? When you go to the beach, when you go to the sea, no matter how good swimmer you are, your parents always tell you that don't ever go to the middle of the sea. Don't ever swim at the middle of the sea. Nobody dare to do so. Even the best swimmer in the whole wide world didn't dare to swim at the middle of the sea. Why? But you can see that when close to the shore, right, you could see even baby could swim, right? Why? Right? This is the seaside. Right, let me explain this a little bit. Yeah, this has something to do with the shallow water and the deep water, right? That causes refraction as well due to the different depth of the water. I want you to remember easier way to do this. Shallow water, you could see that close to the shore. This is shore. I want you to look at my screen. This is a shore. You can see that at shallow water, it seems like all the waves are being squashed together. Right. So it causes the wave length. Do you see that? The wavelength at shore, you could see that the wavelengths are closer. So again, because we are talking about the same water, so that is why the frequency of the water is constant. We are using the wave speed equation to explain this. Frequency is constant. Wavelength is directly proportional to wave speed. When the wavelengths are closer, it causes the wave speed to decrease. So that is why even the baby is very safe to swim as long as you have guardian, you have adults there to accompany the baby. Babies are safe, yeah, close to the shallow water because the speed of the water is not so high as compared to the deep region. Due to depth of the water, you could see that the wavelength here, right? The wavelength seems to be further apart from each other. Could you see that? This is deep water. So the wavelength are increasing. The distance between the wave fronts are increasing. So that is why it causes the wave speed to increase. So the speed of the wave at the middle of the sea is very fast. So that is why it is not safe to swim at the middle of the sea, right? Now, shallow water, the wavelength is smaller. That is why the wave speed is lower, right? Now, for deeper water, the wavelength is longer, further apart, because the wavefronts are further apart. So that makes the wave speed higher. It is unsafe to swim at a deeper region. That's the reason. So now, let us answer some past questions to make you understand the concept better. I'm going to apply the concept of refraction by answering the past questions. This is related to IGCSE physics with code 0625. One of the past questions is this one. Let me read the question. Some plane waves, okay, by the way, before I solve this question, you feel free to pause the video. Since you have downloaded the notes, you can actually try to solve it first before you listen to my answer. How about that? That would help you to even understand the concept even better. So the question, some plane waves travel on the surface of the water in a tank. They pass from a region of deep water into a region of shallow water. Fig 6.1 shows what the waves look like from above. A, state what happens at the boundary, if anything, to the frequency of the wave. Bear this in mind. This is the same wave. Some plane waves, same wave, travel on the surface of the water in the tank. It is still the same water wave. The question did not mention that this water wave has been changed to another water wave. That is why the frequency of the wave must be constant. Frequency of the same wave will always be constant unless you change to another type of wave. Speed of the wave. Okay, if you want to skip this question, I skip this question because from Fig 6.1, I can determine the wavelength. How do I know the wavelength? The distance between the two wavefronts. This is what we call wavelength. Could you see that from the deep water, the wavelength in the deep water is actually larger than the wavelength compared to the wavelength in the shallow water. So that is why when the waves move from the deep water to shallow water, the wavelength decreases. Now, to understand the speed question, you use the equation of wave speed, v equal to f lambda. F is constant, v is directly proportional to wavelength. Since wavelength decreases, wave speed will have to decrease as well. I hope you could understand this. Now, move on. The waves have a speed of 0.12 meter per second in deep water. Wave crests are 0.08 meter apart in deep water. Calculate the frequency of the source producing the waves. State the equation that you use. I need to draw this up because they told you that the wave crest, right? So I'm going to draw the wave out right here. Okay, a bit bending right here. Okay, this is the wave profile of a wave. This is called wave crest. This is also wave crest. The distance between crest to crest, right? This is called wavelength. And wavelength is already been given, which is 0.08 meter. How do you know that's wavelength? Because the distance between the two wave crests gives you the wavelength. So using the equation of wave speed, v equal to f lambda, make f as the subject because you are asked to find the frequency, v over lambda. V is the speed, 0.12 meter per second divided by 0.08, which is the wavelength. So you should end up getting 1.5 hertz. Remember, before we fill in the blank for the frequency, you have to make sure that you put it in terms of minimum of 2 significant figures, maximum of 3 significant figures. So 1.5 together with the unit hertz. That's the unit of frequency. Now, let us move on to IGCSE and Excel Physics past year question right here. The diagram shows changes to light waves passing from air into glass. If you want to determine what kind of phenomenon of wave is being shown by this diagram over here, you just look at the wavelength, right? So this distance between the wavefronts, one wavefront to the neighboring wavefront is called wavelength. Could you see that from air to glass, different medium, and then the wavefront, yeah? The wavelength changes. So this effect is 100% refraction. Reflection means the changing of wave's direction when the wave is hitting the reflecting surface. So you could see that there is no reflecting surface here because wave travels into the glass. So this is definitely not reflection. Dispersion is the spreading of white light. Okay, normally we use white light into 7 different wavelengths when the white light is incident on a prism. Do you see any prism here? So this is definitely not dispersion. Diffraction is the spreading of wave when a wave passing through an aperture. Aperture means an opening. So do you see any opening like this? Okay, aperture means opening. Could be big opening or small opening. So this is called the gap or the aperture. So you could see that there is no aperture here. So this is not related to diffraction. So the answer is refraction. Now, the second part, state 2 ways in which the light waves change as they pass into glass. Remember, when this is about refraction, right? So, go back to my slide. What causes refraction? What is changing? So, effect of refraction. The wave's direction will change, the wave speed will change, and the wavelength will change. So, you just need to mention 2 of those. So, I go back to the past year question. 2 ways. The light wave changes. Wavelength changes. Wavelength changes. And it causes the wave speed to change. Right? Now, B part 1, draw the normal to the incident ray on the diagram. So normal is an imaginary line. I will erase this first so that you can see what I draw here. It is an imaginary line that is perpendicular to the surface of the medium. So the surface of the medium is the surface of the glass. You can see this is the surface of the glass. All you need to do, take out your ruler and draw imaginary line, vertical line that is 90 degrees to the surface. This is called normal. So I better label it as normal. Done. And the second part, label the incident angle, angle of incidence on the diagram. Incident angle or the angle of incident is the angle between incident ray and normal. This is called incidence angle. That's all, right? So I hope you gain benefits from these slides over here. And please feel free to download the notes. But if you have any hesitation, any of the topics that you find it difficult and you want me to make a YouTube just for you, do comment below. Yeah, meanwhile, you could also subscribe to my TikTok channel, to my Instagram, or you join my FB group to ask more questions. Right, thank you very much for watching, and I hope you gain benefits from it, and I'll see you in my next video. Bye.